Okay, something else I wanted to add, and this just seems like it was the other video was a bit long to begin with, and so, but I did feel like there was an important thing to bring up, and that is theory versus reality and other problems. You know, I kind of explained some of these things, and it may leave you the impression that it works fine, that it will be a good tool to use, and you know magical ways of doing this. The truth is that there was a lot of trial, error, and failure in getting this challenge. And even when I was thinking that something would work, uh, I'll just go and talk about some of the problems that occurred that for time reasons I cut out of these videos, but I do want you to be aware of them. If for nothing else, then I think there's some value in knowing that some of these things don't come easy. And so one of the first problems that I got was import failures. And so this happened right off the bat. You know, so the FEC database is like more than 9 some million records. I really only needed a small subset of that for people around the area of this nonprofit, and the FEC database was, nationwide. But it meant that I could not open it with any of the files that were, or any of the programs that were on my computer when I first started this challenge. You know, Notepad crashed and all of these other things that if you try to open with a text editing document, it just did not work. I ended up having to get a text editor that was, I don't know if it's pronounced Beam, it's like VIM. So it's a GNU software, so it's open source. But the important thing is that when I got the database from the FEC, or got the file from the FEC, downloaded it, it came as a CSV file, which stands for comma separated value. So the delimiter there is supposed to be a comma. And what I found out later is that the delimiter is actually a pipe delimiter instead of a comma. And so that threw me off. And so once I found that out, I thought, okay, great. Oh, that's the problem. Let me go ahead and move forward. And so I tried to import it after that and failed. And so what happened in this one was harder to find than the incorrect delimiter being listed, and that was delimiters were being accidentally escaped by backslashes. And so I did not know that those escaped delimiters, it didn't matter, they shouldn't have been there to begin with. But that's why I say it is, the theory versus the reality. And in reality, even though you should not have escaped delimiters, data should have been put in a way that this is not possible. That's only the theory, and when you're working with these large data sets, you will find in reality that delimiters will be escaped, and you will have to deal with those problems. So now that you know about it, you don't continue to hit your head against the wall like I did for a bit, trying to figure out why is this not importing, thinking that things were wrong with my column headings, things are wrong with my data types. No, just escaped delimiters. Another thing, I told you in the previous video that I had a 66% match rate, and that is true. That is the rate that I ended up with, not the rate that I got on the very first time that I tried to do this. So I don't know what that first effectiveness rate was. It was really low because when I began looking at people and verifying whether or not I just wanted to do a couple of spot checks and see, is this person really not in both databases? And with the spot checking, what I found was a whole lot of people that were in both databases, even though the query was saying they shouldn't be. And the culprit turned out to be things like this. And this is just one of them, I will say, but it's one that illustrates a point. And you know how I said that there's a lot of variation in first names, but there's no variation in last names, or you would think that there would be smaller variation in last names. Well, that was an incorrect assumption. And it was incorrect because of things like this. And hyphenated names was one of them. Having a hyphenated name, so you can have Joan Smith. Some of them had been hyphenated, some of them were no hyphenations, and with things like this, or it was just input incorrectly. This is where I say looking at those false negatives and trying to figure out what caused them is important. And I was able to solve a lot of this by clustering data sets in OpenRefine. And so there are a couple of clustering algorithms that allowed me to do this and make the pseudocode have a higher match rate, I should say. Okay, other things that happen. Forgetting to ensure unique primary keys. And this is actually related to the bullet point right above it. So I used OpenRefine to cluster the pseudokey combinations so that if in one table it was Jones hyphen Smith and in another table it was Jones Smith, and I used the clustering. Well, now that I've clustered those values and made it one variation and assigned that value to all of them, I needed to take that one variation and go back to the original table and put it in. And what I found out was that I had destroyed my unique primary key. And how that happened was just simply, just not thinking for a moment. I said, okay, I need the primary key from this table, and I only need two columns, right? I need the primary key column and then the pseudo key column, and then cluster on the pseudo keys. Well, it turns out that method did not produce unique primary keys. What happened was I had auto incremented the rows on both tables, and so a kind of easy example of this is, think of the first 40 records in my FAC table had a primary key of 1 through 40, and the first 40 rows of my constituent table had a primary key of, you guessed it, 1 through 40. And so it was just bad. And fortunately, I caught it before I did any SQL commands to overwrite, and I ended up needing to, I still used a auto number, but what I did is I attached a prefix to it to make it a unique primary key, and so I attached like the letter F in front of that 1 through 40, so I have F 1 through 40, and then attached C for the constituents table, and so I had C 1 through 40, and so when I added both of these, or I placed the sets of records from both tables into one, I guess you'd call it a view with 1 through, not 1 through 40, but F 1 through 40 and C 1 through 40 in the same column, and then the pseudo keys in the same column and clustered on them and picked a single variation, I could now go back and put those pseudo keys into the original FEC and constituent tables. So again, always good to know that there are mistakes that you can and will make in this. The process was not seamless. The really big takeaway I get from doing this challenge, because like I say, I'm doing these challenges as a form of learning. I did not know how to do a lot of the stuff before, especially in SQL. And so the big takeaway is that this is a highly iterative process. It's a process where you start with a matching efficiency of, maybe in the tens of percent, but a few tweaks, and I'm getting a matching effectiveness rating of 66%, which is more than enough for the process that I was trying to do, because I needed such a small number that I was going to focus on, which was people with big spending in the donations. So yeah, that was my takeaway. I just wanted to take a couple of minutes here and enlighten you, especially if you try to do a challenge like this, that it is not going to be a simple process. You're going to have to go through it, hit a dead end, and then come back, start over again. Hit another dead end, but it's a dead end further down the pathway in the journey here. And I don't want to give the impression that I just picked this up and it worked for me. So I always think it's good to note some of those things, especially in the beginning and especially in the learning process. And I hope that these two videos, taken together or separately, have been informative. And from here, let's continue with the SQL portion of it and see how I used PostgreSQL to solve this. All right, let's go to the program.